Good morning, everyone, and welcome to the Teaching Factory Knowledge Sharing Network's Industrial Webinar. My name is Fotis Stamatopoulos, and I'm a research engineer at Laboratory of Manufacturing Systems and Automation, LMS, located in Patras, Greece. Today with me are my dear colleagues, Harry Bikas, also from LMS, John Stavridis from Prima Additive, and the original plan would be to also have Corner Lash with us from Volvo Trucks, but unfortunately he tested positive for COVID, so he won't be joining us for today. So going into the agenda for today's webinar, we are going to have a short presentation of the teaching factory paradigm and how it is applied in the context of the TF KnowNet project, especially how it links industrial and academic partners and what are the benefits of this mutual exchange of knowledge. Then we are going to have some industrial testimonies from our industrial partners about the piloting activities performed in the past and what are the challenges, the added benefits, and of course, what is planned for the future, so future activities. And finally, we're going to have a short Q&A session where Harry will also present how interested potential partners can join our network. Harry, I think you can start with a presentation of the TF KnowNet project. The floor is yours.
Thank you, Fotis, and welcome also from my side. So we are going to present a bit at the beginning what the TF KnowNet project is about, what the teaching factory is, and how it operates. And we are going to discuss a bit our experiences so far in the project, both from an industrial mainly, but also from an academic perspective. And also we are going to do a Q&A session, as you mentioned, on how potentially interested people could join the initiative. Starting from what TF KnowNet is and what the teaching factory is in general. When we look at the notion of knowledge, we know that this comprises different skills and different competencies. And we know also that skills and competencies that are required by the labor market evolve at a very high rate. We have a very large percentage of the core engineering skills needed from the companies having changed over the last few years, and these skills are going to change even more and start leaning towards multidisciplinarity quite a lot, creativity, and what we call soft skills that cannot be effectively taught in a typical classroom. Also, due to the rapid evolvement of the skills that are being required, academia needs to be able to follow the industrial needs in order to generate the right kind of professionals. What we see on that is that Europe has a lot of companies, a lot of manufacturing companies that are mainly small and medium enterprises that need access to this kind of skills and competencies for their employees. But at the same time, they don't have the means to train them internally. In parallel, Europe also has a very well developed educational system on every single level. And most of the universities and vocational training institutions also have quite a lot of equipment. However, this equipment is a bit dispersed and is not being utilized at its full potential. The idea here is to try and bring somehow what the university offers and what the company needs a bit together. The idea is that the educational institutes should be in a position to understand the industrial challenges and should be in a position to offer training very much linked to what the industry needs, ideally being able to provide hands-on training for the students, but also in terms of reskilling and upskilling employees and bringing those skills directly to the labor market. So how do we address this concept? How do we address this problem through the teaching factory concept and through TF KnowNet? The idea is to use the established teaching factory paradigm, basically a two-way street where from the factory practitioners teach students and from the classroom students and faculty teach practitioners, and bring that to a network level. TF KnowNet has established such a network that links industrial and academic nodes and facilitates the launch of collaborative manufacturing and training projects with mutual interest both for the industry and for the academia. The participating organizations can effectively exchange information, and this includes teaching material, virtual access to state-of-the-art infrastructure, industrial challenges, and novel solutions. The network also functions as a virtual forum of actors around the knowledge triangle integration in manufacturing. The organizations that participate in TF KnowNet are effectively classified in two boards. We have what we call the academic board, which is mainly universities and research centers, that focuses on providing novel concepts, approaches, and remotely accessed testbeds to address both industrial needs and innovative educational schemes. And on the other hand, we have the industrial board, which has the chance to express their needs in terms of training and upskilling, as well as provide a number of industrial challenges that that can be solved collaboratively with participation of people from each of the different nodes. In this case, we also have a series of virtual classrooms and virtual working space that can enable collaborative teaching and collaborative training, as well as collaborative solving of different solutions. The whole network can operate in multiple knowledge transfer modes. We have the industry to academia knowledge transfer mode, which aims at transferring the real manufacturing environment to the classroom through the adoption of an industrial challenge or industrial project, involving one factory in simultaneous interaction with one or multiple academic entities. This interaction can involve discussions, presentations, live videos from the production, or other knowledge delivery mechanisms. We also have what we call the academia to industry learning mode, and this aims at transferring knowledge, state-of-the-art knowledge from the academia to the industry. In this particular case, we have training of industrial personnel in state-of-the-art technology, as well as transfer of technology from academic testbeds to the industry. Again, this interaction can involve live audio and video connection between the industry and the academia, as well as remote interaction with the physical testbeds that are present in academia through advanced ICT. Last but not least, we have piloted over this last couple of years what we call academia to academia exchange mode. And this exchange mode is basically aimed at linking together academic nodes, each one having a specialized know-how in different area and specialized equipment that is quite diverse, and bringing them together in order to collaboratively work in solving problems and training students in specific subjects. How do we achieve that? So the teaching factory in general is facilitated by advanced ICTs and high-grade industrial didactic equipment, and operates as a non-geographical anchored learning space. It is a bi-directional knowledge communication channel that brings the real factory to the classroom and the academic lab to the factory. We have a context and content modular configuration, allowing learning and training on multiple study contents, and this engages different factory facilities, engineering activities, delivery mechanisms, and academic practices. You can already see on the screen how a typical teaching factory looks like, both in terms of interactions through ICT tools and the teaching factory platform facilitated through Microsoft Teams in this instance, as well as how a typical cycle of activities looks like in the context of a teaching. In order to validate the proposed framework and the applicability, a number of pilot applications have been implemented so far. We have implemented more than 12 pilot activities across 8 organizations, and including so far more than 250 trainees across 14 different countries. And we are going to see a couple of examples from that. The first example is an academic pilot that was run in order to introduce students to cyber-physical production systems. This was run as a collaboration between four academic partners, namely LMS, Aalto University, Polytechnic University of Milan, and TU Braunschweig in Germany. And tutors and lab facilities from all 4 partners were utilized, while trainees also came from all 4 participating universities. Overall, 23 students participated in the activity, and the pilot had an overall duration of 7 weeks, with live sessions taking place every week on a fixed time slot, and where the students had to deal with different subjects, such as data collection and analysis, simulation of manufacturing systems, and the optimization of the system. A slightly different academic pilot has also been run in the previous years, introducing students to manufacturing processes and eco-efficient manufacturing. In this particular case, students were called to design, manufacturing, and validate a new skateboard with removable tracks that is able to be turned into a snowboard. This challenge was the design and manufacturing should meet the quality standards that the market expects and fulfill also the current social and environmental challenges. This was a project work that was allocated to students from two universities, in this particular case, LMS and Mondragon University from Spain, and had an overall duration of 11 weeks. And at the end of the day, the students were able to create and produce these convertible, let's say, snowboard, skateboard devices that you see on the screen. What you saw was just a very short video of the activities that took place during that pilot, and this was executed as a distributed manufacturing example, actually, with some of the components being manufactured in LMS in Greece, some of the components being engineered and manufactured in Mondragon University in Spain, and then brought together to create a complete product, thus creating also the necessary skills in the participants that took part in the pilot. Besides that, we have also run a series of industrial pilots that are not presented in detail here, but we are going to discuss about them in the next few minutes also together with John from Prima Additive. And in that particular case, the industrial pilots focused both in training employees of the companies in state-of-the-art solutions, but also solving industrial challenges. So a company that has a specific challenge that needs to find some ideas around that, describes that challenge, university responds to that challenge, and student teams start working using project work in these particular challenges, developing solutions. This whole schema is very beneficial both for academia and industry. If we take a look at academia, we see that this is a new learning experience for both students and the faculty that is not available in purely theoretical lessons, and it cannot be available in purely theoretical lessons. It gives the ability to the students to deepen their knowledge and apply it in practice, as well as generate real impact outside the academic environment and bringing them in close touch with the industry. On the other hand, we see that the activity adds value for the industry themselves by facilitating production innovation, offering new ways of thinking and demonstrating new solutions, providing solutions to industrial challenges, providing the access to a talent pool, and at the end of the day, bringing new ideas from the academia and novel concepts to the industry. This was a short summary of what we do in the activity. If you are eager in learning more, you can refer to our website, but also on our social networks. And of course, if you have any more questions that you would like to discuss with us, or if you are keen in participating in future activities, feel free to reach out to us. We would be glad to accommodate any requests on that front. And that was all on my side in terms of summarizing the activity. For this, I think that the floor is yours.
Sorry for that. Thank you very much, Harry, for providing a pretty much great summary of what the TF KnowNet concept is about and how things are handled during the TF KnowNet project. Also, thank you for mentioning all the modes of knowledge transfer, or the possible modalities, the different kinds of pilots between academia and industry, and also how a typical TF pilot works. So how are the cycle of activities, We saw also an example of an academic pilot, like the one where students designed and manufactured that hybrid snowboard/skateboard. And also at the end, we saw some of the benefits that are for the industrial partners as well. So it's not limited just to academic partners. And moving on from that, I'd like to introduce John Stavridis from Prima Additive to have a sort of discussion on what kind of piloting and activities were performed that the Prima Additive has participated, and what were actually the challenges of implementing this approach, because in theory everything sounds great, but when in action things are not always that easy.
Hello from my side. Hello everyone. Nice to be here with you and discuss on the outcome of the project. I would like to highlight that Prima Additive has participated in various pilots in this period of the project, both on industrial academic, let's say, relation, and in industrial to industrial, let's say, pilot cases. Regarding the first aspect, Prima Additive, together with a partner, has organized a pilot case with the students, where Prima Additive has selected a particular component, and the students were asked to orient and program this component to be breeding with powder bed technology. The challenge here for the student was to understand the necessity of the process, together with us, after some training that we have done to the students, was to identify the criticalities of positioning a part on the powder bed, how the recoating can affect the defects of the part, if there are or not, and how you can redesign it in order to take more advantages of additive technologies. Regarding this first pilot, I can say that the experience both for the academic side, also for us, was important. We have identified how a student mind can approach this kind of problems, how a student that does not know before the additive can quickly adapt to the needs of the technology. The target was not to make everything perfect from the first time. We wanted for the students to have the opportunity to learn and clarify and think why we had this outcome by positioning the part like this, and why we had the other outcome by positioning the part like that. So the whole procedure was important both for student and for us, that we took an idea how to approach new engineers that come out from the university in order to implement them in our structure. On the other side, we have participated also in various industrial cases where we were asked to provide some info, our vision, our approach for the business development in additive manufacturing, and the costs that the additive manufacturing can have. It's a discussion that has a very high importance for additive market in general, because we need to make known that additive is not only costs and low productivity. We need to say that with the right application, the additive can be competitive. We have demonstrated some cost models where some calculation can be made and identify the advantages of additive. Also, our business approach as company that includes the relation with research centers and academic environment can facilitate the industrial uptake of additive manufacturing and provide advantages both for academia, industry, and also learn to the new engineers and to the pool of the new guys, the new engineers that will be the experts of the future, how to approach the additive and how they see the additive in the market today, and where are the possibilities and the capacity to grow within this market. So
Thank
more
you
or
very
less
much,
these
John.
are.
Sorry for interrupting you. Go ahead.
No, don't worry. No.
So thank you very much for presenting the two pilots that Primadditive was a part of. It was pretty interesting to see how you can utilize and pretty much share industrial grade equipment between partners. In this case, your Paderbed Fusion equipment. So students were, let's say, able to use even remotely some industrial grade
Yes,
equipment and see how industry works in real life cases. And also that
just to highlight that, sorry for interrupting, just to highlight that we have printed these components that the students designed and programmed, and the outcome was discussed with the students. They saw the errors, or they saw what they did well. So all this comparison helped a lot.
Otis, if I may add something to
sure.
that one, that's very important. And, John mentioned two things that I think should be highlighted quite a lot in the context of what TF KnowNet does at the end of the day. We are bringing knowledge together, we are bringing competence together, and we are bringing people together to work on projects of mutual interest at the end of the day. What was mentioned by John, what was just mentioned by John, so and by you as well, so that the students being able to use or virtually use, let's say, a powder bed machine, it's something that wouldn't have happened without TF KnowNet from our perspective. The reason for that is that we don't have access locally to such equipment. Therefore, the students would not have the opportunity to experience that. And we think it's a good thing, and it's a good thing not only for us and the skills that the students acquire. It's a good thing also for someone that looks for employees in 1 or 2 years' time that actually have these skills. So it's very important also for the industry to be able to generate this kind of professionals that know already or have at least a very good feeling on what happens in such state-of-the-art technology. The second part that I would like to mention that was not was mentioned by John, but I think it should be highlighted a bit more, is the participation of Primadditive, in particular in this case, in industrial pilots, in knowledge exchange between industries. This is also something that's rather important. So in this particular case, we had a challenge that was imposed by Volvo in terms of getting a group of design engineers to understand additive manufacturing and understand how they can design for additive and how they can take additive into production for their specific applications. It's a pity that we couldn't have Lars with us today from Volvo Trucks, because he could have explained that from their own perspective. But the important thing here is that we were able to provide academic training on additive manufacturing, and obviously the academic perspective is always slightly different. So we provided a lot of knowledge on certain things about additive, but they also had the chance to see some things from the perspective of a company that actually produces parts with additive and produces additive manufacturing machines. That's rather important in this particular case, and gain the perspective on how additive can be profitable in terms of business models. We are talking quite a lot about additive. This was just to mention that this was just a specific example. TF KnowNet will go above and beyond additive manufacturing. It's just a very good example to demonstrate what has happened here. For this, you said at the beginning, it was not all, not everything was perfect, obviously, and we had a number of challenges in the implementation of those pilots. But maybe from just from the academic perspective, if we are to discuss about challenges, it's sometimes difficult because the concept is relatively new to convince students to embark on something that is not usual classroom-based lecturing for them. It's quite difficult not to capture their interest, I would say, but to get their commitment in something that's totally different from what they have done before. We have seen that the interest there is increasing, but this could be a potential, let's say, barrier from the academic perspective on getting these activities up and running. John, I know that you also faced certain challenges within embarking in this kind of activities in terms of devoting resources, etc., which are to be expected, let's say, from an industrial partner. Would you like to comment a bit what an industrial partner might find challenging in starting such a project?
Yeah, that's a good question. I mean, industry is a very busy, let's say, sector. We have our times and we have our time frames, and our deadlines that are very, very difficult, and we need to respect them because, if you don't respect them, then you don't have at the end, the sales, and at the end, you don't proceed with your business plan. The challenge for us was to allocate, let's say, the needs of the project within what we are already doing. Because sometimes the companies are reluctant to participate in a project like this because they think that they take time of what they do, they occupy resources from what they are doing. In our case, it's not like this because our total approach, business approach, and how we want to communicate additive to the public and to the market and also to the academia is different. We are looking for those synergies in order also to start educating people, the new people that we need after some years to equip. We will need them as staff in our company. So for us, it's important. For example, if we have an application that we want to do for a client, we can combine this task with the necessity to learn and to teach the new engineers under this umbrella of this project. So you can combine different tasks and have the same advantage for you. The client was satisfied, we did the part, and also at the same time we involved the students in order to assist, to learn, and to understand the process. So again, the companies must not be reluctant to this. They need to be open to teach new engineers, especially on the upcoming technologies, on the new technologies, and they can combine different tasks that are, let's say, there are some conflicts. They can combine them, and at the end have advantages for both the parties. So at the end is a choice of the company.
I would actually phrase it more like an investment. You waste some time at the
Exactly.
start and you earn back that multiple times before.
Exactly.
Because the people you employ are way better, they won't need to spend that extra time learning. And they also learned already from their errors, so they are ready to go to work without having so much fear of, let's say, a new challenge.
Exactly. It's
And
not
also,
something that you will see the outcome right now. It's a long-term vision, a long-term approach. But it is, like you said, it is an investment at the end. And you can combine it with your current activities, even if they are the most urgent activities in the world.
Obviously, if I may add something to
sure.
that in terms of benefits, I would add that sometimes you get a similar benefit in terms of training also for the company employees. I'm just thinking some of the other activities that we had within the project. But if you take, for example, a particular challenge that needs development of a specific technological solution, because the students and the student groups that are solving this particular challenge will approach that from different perspective and potentially using different technologies and for sure different approaches. What we have sometimes is also the people that propose the challenge, so the engineers from the company that propose the challenge and follow along the challenge, learn about new technologies that they can apply in their production. This usually has to do with the application of digital technologies, machine vision, things like AI, you name it. They see that they could potentially benefit from application of those technologies in the production. So there we also have a win-win cooperation, let's say, because the company gets some ideas about how they could potentially solve this challenge. These ideas might be applicable to additional challenges that they face, the engineers from the company get a very good overview of what technologies are available that potentially they haven't considered before. And obviously, this has immense benefits for us as academic partners because our students get to apply these state-of-art technologies, AI, digital twins, machine vision, whatever, in a real industrial environment. So I don't have to tell them about AI in the classroom and just give silly examples that come out of my head. I can have them work on a specific application that comes from a company that it's there and they will have to face in their professional lives. Then they also develop a series of soft skills that we've mentioned at the beginning. This includes working in teams, working in strict deadlines, getting in touch with industry and having an actual discussion and exchange with industry. So this also comes with a lot of benefits for us, of course, and this is part of why we do that. But comes also with a number of benefits for the industry as well. Just a small addition from my side on what we have seen over the last couple of years.
That was a great addition, Harry. And let's say moving on from that, we see that it's like a continuous process. It has some iterations. So you start from something, you developed another thing. We saw it with Volvo, for example, this year. We started with, let's say, a more generic and academic approach. So teaching a group of a lot of engineers about the baseline, the base technologies of additive manufacturing, etc. And this sparked, let's say, some extra challenges that were the outcome of the original pilot that had to do with real parts. So what is another like great benefit of this procedure is that one thing leads to another and into a continuous cooperation that you can do more and more complex stuff over time. And also by combining, let's say, the both academic partners' expertise and industrial partners' expertise for another industry. So we saw the, let's say, the communication that Prima had with Volvo, how can they cooperate on things, and how they can also make some business deals out of that. So there is a lot of benefit there for all parties involved. And I'd like to ask, because we are, let's say, running a bit over time, if you want to mention some things about the next action, so something that is planned for the future, and like a final overview of how can somebody that's interested in all those things, how can he join the project?
I guess that's more for me, but John, of course, if you want to jump in, feel free to. Starting from the first part of your question, what comes in the future? We know already, all the consortium partners know already about the benefits of the approach because we have seen that firsthand over the last few years that the activity has been running. So the immediate goal is to actually continue doing what we have been doing for the last 2 years. There's a never-ending number of industrial challenges that wait to be solved. So we foresee to have a few of those elaborated on within 2023 and onwards. And we also we would also like to retain the aspect of the academic pilots, so pilots between academic partners as well, because we think they are a very good fit within our curricula. They're a very good way to train our students beyond the classroom. Besides that, we are always looking for new challenges. We are always looking at expanding the network. The TF KnowNet as a funded activity ends at the end of 2022, so in a few days' time. This does not mean it disappears from the face of the earth. We are still going to be here as a network. We are open in applications from industrial partners that have challenges or wish to be trained on certain topics. And this brings me nicely to the second part of your question, how people can get in touch with us. So you can reach us through our website. We do have an application form if you want to submit a challenge to us. You can reach us through all social media channels that you can see on your screen and through the contact email that you can also see on the screen. And we would be glad to discuss and accommodate challenges or requests coming from the industry going forward. The same also applies if you are an academic partner, by the way. So the network is open We want to enlarge that. The benefit here is the people, is the network. So everyone is really welcome to join. Feel free to get in touch.
Thank you very much, Harry. That was very clear. I don't know, John, if you have any last remarks or we can conclude today's webinar.
Yeah, just one word from our side. We will seek also to continue the collaborations obtained from this project. As you mentioned with SAB, we already are trying to understand the new application and develop it together. Also, we are at disposal in order to continue and to uptake this kind of collaborations between academia and industry. For us, was a very good experience.
Thank you very much, both John and Harry. And I think we can conclude today's webinar. Thank you, everybody. And if you're interested, don't be afraid to contact us through the channels that Harry has provided.
Thank you. Have a
Bye
nice
bye.
day. Bye.
Okay, thank you very much.